You know, the real power of AI for any business truly comes alive when it can understand your specific data. But there's a huge challenge, right? Most of that crucial information, all those emails, reports, and internal docs, it's just unstructured text.
So, the big question is, how do we get these incredible general AI models to connect with the unique world of your organization? We need a way to make them understand the context and the language that you use every single day.
Well, the solution is all about breaking through the biggest bottleneck in AI today, figuring out how to translate our human language into a format that a machine can actually work with, mathematically. We have to turn our words into meaning it can understand. And that's where something called text embeddings comes in. The best way to think about it is like creating a detailed map of meaning. It's a process that turns text into a set of numbers, a vector, where concepts that are alike are placed close together, and ideas that are different are pushed far apart. And this is a huge deal. This ability to map out meaning is the engine behind so many modern AI tools. We're talking about semantic search that gets what you mean, not just the keywords you typed. It's what powers data clustering, recommendation engines, and it's absolutely critical for retrieval augmented generation, or RAG, which is how you get large language models to use your documents as their brain.
But here's the catch. Creating these embeddings efficiently has always been tricky. And that brings us to a really innovative new model that's designed to give us the best of both worlds. Let's talk about Luxical-One.
So for the longest time, you've had to make a tough choice. On one side, you have these older lexical methods. They're super fast, super simple, but they totally miss the meaning behind the words. On the other side, you've got these powerful deep learning models like transformers. They create what we call dense embeddings. They're incredibly smart and nuanced, but oh man, are they slow and expensive to run? They usually need beefy GPUs.
Right, so you were stuck. Speed or smarts? You had to pick one. Well, Lexical-One is built to completely eliminate that trade-off. It's a hybrid model that gives you both.
And when I say fast, I am not kidding. We are talking anywhere from 3 to a whopping 100 times faster than those complex transformer models. And the real kicker? It hits these speeds running on a standard everyday CPU.
On top of that, the model itself is tiny. At just 930 megabytes, it's so small you can run it on almost anything, from a big server all the way down to a laptop with no special hardware required. Okay, talk is cheap, right? Let's actually see how this thing thinks. We're going to do a quick and practical similarity search to see it in action.
All right, let's start with our first sentence. The weather is sunny. Pretty simple.
Now for our second one, something that means basically the same thing. It's a beautiful day.
And for our third sentence, let's throw in a curveball, something completely unrelated. Pizza is my favorite food.
Now, watch what happens when we run these through Luxical-One. The scores here tell the whole story. A 1.0 means it's a perfect match with itself, obviously, but look at the score between the first two sentences, 0.84. That's super high, which shows the model gets that they're semantically related. And when you compare either of them to the pizza sentence, the score tanks. It knows they have nothing to do with each other.
Pretty cool, right? So now you see what it can do. But the real question is, how does it pull off this incredible mix of speed and intelligence? Let's pop the hood and take a look.
The secret sauce is its architecture. It's a really clever multi-step process. First, it does a quick scan of the text using a classic fast technique to find common word patterns. Then, and this is key, instead of a heavy neural network, it uses a super efficient mathematical calculation to map those patterns. Finally, there's a tiny optional layer that refines the result, adding a bit more nuance without slowing things down.
And the way it learns is just as smart. It uses a technique called knowledge distillation. Just imagine a small, agile student model, that's Lexical-One, learning from a giant, powerful teacher model. It learns all the wisdom and intelligence of the teacher, but without inheriting any of its slowness or bulk.
So let's zoom out for a second. What does all of this really mean? It means we're looking at a future where seriously powerful AI can run on the hardware that we all already have. It's about democratizing semantic AI. So let's just recap the big wins here. First, it runs entirely on standard CPUs, no expensive hardware needed. You get blazing fast speed, but with high-quality semantic understanding. The output vectors are compact and efficient, and it's just as good with short queries as it is with long documents.
And this is the real game changer. We're talking about a fundamental shift. moving high-performance AI away from being locked down to expensive GPUs and putting it right onto the everyday CPUs that are in nearly every single computer on the planet.
The bottom line is simple. Powerful, nuanced AI that understands language is no longer just for the big players with massive budgets. This kind of technology makes high-performance AI accessible and ready to go on the hardware you have right now. So the only real question left is, with this kind of power in everyone's hands, what will you build?